In this video, we're going to discuss the idea of consumer and producer surplus. So the idea here is that by selling at the equilibrium price and by buying at the equilibrium price, the consumers and producers are both gaining something. Because if you look at a supply and demand curve, you would notice that suppliers are willing to build and sell something for a lower price, and producers are willing to buy something at a higher price. But those two prices come together where both parties are willing to meet at, and as a result, they're both saving some money. Okay, so let's start with the idea of consumer surplus. Consumer surplus is the gain from trade. In other words, it is measured as the total amount that the party saves by paying the less price. So if you notice here graphically, this area in blue, this area here, between the equilibrium price and the price the consumers would have otherwise been willing to pay, that area is the consumer surplus. That's the money that they are saving by actually paying the equilibrium price. The producer surplus, the additional amount that the producer is making, is the total amount gained by selling at the equilibrium price versus the lesser price. In other words, we're referring to this area here. So in calculating consumer surplus and producer surplus, we're trying to calculate that specific area, those two triangles, or they're approximately a triangle, not exactly. And we know the areas of a triangle are approximately 1/2 base times height. So here we're given a supply and demand curve, and we're going to look at how you actually calculate these values, what consumer surplus and what producer surplus would be. So to start with, we need to find the equilibrium price and quantity before we can make these calculations. I would say the equilibrium price and quantity appears to be this point here. That looks like the equilibrium price. The equilibrium price is $8, and the equilibrium quantity looks like about 350. So we want to compute consumer surplus. In other words, if we draw a line to our equilibrium point, this area here will represent consumer surplus. So we're trying to find that area. Notice that area is approximately a triangle. Area equals 1/2 base times height. So we need to figure out what the base of that triangle is and what the height of that triangle is. Well, if I look for this particular triangle, if we're going to call this space here the base, notice that's actually the same thing as the quantity, the equilibrium quantity. So I would say the base is 350. The height would be equal to this space here. The height would equal that highest possible price that the consumer is willing to spend. In this case, that looks like 22, minus the equilibrium price, 8. So I would say here that the height appears to be 14. So area equals 1/2 times the base, which is 14. And so that area, which is the same thing in this case as our consumer surplus, equals 2,450. In other words, the consumer surplus equals $2,450. That means the consumers that would have otherwise spent more money on this product have now saved $2,450. So I'm going to erase those things real quick just so we can now go back and do the producer surplus. So let's begin first again by looking at the approximate triangle that would represent our producer surplus. And that would be this area in here. So to compute our producer surplus, again, area equals 1/2 base times height. If I think about this as an upside down triangle, I would think about this area here as being the base of my triangle. And again, that's the same thing as the equilibrium quantity, which would be 350. The height of the triangle, this space here, is equal to the equilibrium price of $8 minus the smallest price that the consumer would be willing to produce this, which is $2. So I would say the height here equals 6. So area equals 1/2 base times height. This area equals 1,050. So the producer surplus is $1,050. That is to say the producer makes an additional $1,050 by selling at the higher price versus the price they would have otherwise been willing to pay. So we understand this graphically. Now we're going to see if we can do this from a function. And really I would say it's best to eventually get to where you're considering the graph, because that helps you recognize the area of the triangle. But let's just start where we want to find the equilibrium price and quantity given this supply and demand. So it's saying supply is P equals 1,000 plus Q. And for demand, P equals 1,500 minus 3Q. So if we want to find the equilibrium price and quantity, we want to determine where these two things are equal. So we want to know where 100 plus Q equals 1,500 minus 3Q. Okay, so we're just going to solve this algebra equation. So the first thing I would say to do, maybe add 3Q over 100 plus 4Q equals 1,500. Subtract 100 over 4 cubed. 4Q equals 1,400. And dividing by 4, we would get Q equals 350. So that means we're expecting to sell 350 of these items. To get price, notice how we set these two things equal. You could pick either price function. It wouldn't matter. You would get the same value. So I'm going to pick the easier one. Price equals 100 plus 350. So price equals 450. So we've determined the equilibrium price and quantity for this good. Now we want to find the consumer and producer surplus for this product. So what I would say I would do first is I would start with considering what these two things are going to look like graphically. So we're going to make this graph. And here's quantity. And here's price. And we know that these two graphs are going to meet at 350 and 450. So what I'm going to do is I'm going to make this axis over here. I'm going to do 500, 1,000, and 1,500. Because I know for my demand curve, the y-intercept is 1,500, so I at least need to be that high. And then I know these things are going to intersect at 350. I'm going to go a little bit past that. So let's say for this axis, I'm going to do 100, 200, 300, and 400. So to make these graphs, it's really not going to be as difficult as you think, because you actually know enough points to kind of make them come together. You know both of these graphs are going to meet where quantity is 350 and price is 450. So on both of these graphs, I'm going to have a dot at 350 and 450. So let's graph this P equals 100 plus Q graph first, our supply curve. The y-intercept would be 100, and then we know it must go through that equilibrium point. So here's my supply. Similarly, for my demand curve, I know the y-intercept is 1500, and it must also go through this point. So there's demand. So pretty easily I can kind of sketch these two graphs, and once I have the graphs, then I know how to do consumer and producer surplus. So let's start with the consumer surplus. I'm going to quickly shade in that area. So here is my consumer. We want to calculate that area for consumer surplus. And area equals 1/2 base times height. The base of that triangle, the width of it, is the same thing as the equilibrium quantity. The base here is 350. The height is the difference between the maximum point that the consumers would be willing to pay in the equilibrium point, the price, which is 450. So 1500 minus 450, that height equals 1050. So the consumer surplus, the area, will equal 1/2 times 350 plus 1050. That area, or consumer surplus, would come out to be $367,500. So the consumers have saved quite a bit of money. Now let's look at the producer. The producer surplus would be this red area, this red triangle. We know area equals 1/2 base times height. I would say the base there is going to be the same value. It's an upside down triangle, but it's going to have the same base as the consumer curve, which is 350. The height would be the difference in the actual equilibrium price and the price the consumers would be willing to produce it. So the equilibrium price of 450 minus the 100, that would be 350. So area equals 1/2 350 times 350, which will come out to $61,250.